Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on problem solving on network topology. So here the first problem here determine. So first for the circuit, find the circuit, draw the oriented graph and write the incident matrix and tie set matrix and cut set matrix. So first this is the network. So for this network, first find out the draw the graph. For the graph here, for the circuit, draw the graph first here. How you will draw the circuit graph first here? The all elements are replaced by line segments. Current source is replaced by open circuit, and voltage source is replaced by short circuit, and assign the directions. So for drawing the oriented graph, first what are the steps? Here step 1, replace all elements. Resistors, inductors and capacitors are replaced by line segments. Here all passive elements, resistor, inductor and capacitor. So now here what are the elements here? This one resistor, and next this resistor and this one all are replaced by short circuit, and inductors are replaced by line segment, not short circuit, line segment, and capacitor is also replaced by line segment. So this capacitor. Next, this resistor is also all passive elements are replaced by line segments, and next voltage sources are replaced by short circuit. This voltage source is replaced by short circuit, voltage source is replaced by short circuit, and next current source is replaced by open circuit. This current source should be open circuited, not short circuit. And next assume the directions of the branch currents and number all nodes and branches. So now if you simplify this, so this is the graph. So this one and this one and this one and this one. So this is the graph, and here it is the graph. So this is not, it is open circuited. So now the graph should be like this. So now assume the directions first. Here you can represent in any direction. So the direction should be like this, and number all the nodes and branches. Here node 1, node 2, node 3 and node 4. This is node 5. Next branch 1, branch 2, branch 3, branch 4, branch 5, branch 6 and branch 7. So here these are the branches and nodes. Total number of branches are here 7 and total number of nodes here 5. So now here how you will determine the incident matrix. Incident matrix can be drawn. Incident matrix is represented with A. So it is number of nodes crosses, number of nodes cross number of branches. So next tie set matrix, next F cut set matrix. So first here this is the incident matrix. So it is represented with A. So number of nodes crosses N cross B. Now here if this incident matrix elements are 0, this matrix elements are 0, 1 and minus 1. If it is entering to the node, so if it is leaving away from the node, it is plus, and if it is entering to the node, that is minus. So if branch orientation is leaving away from the node, that is plus 1, and if it is entering to the node, that branch orientation entering to the node means that is minus, and if it is not associated, branch orientation it is not associated, then that value is 0. So now here incident matrix values are 0, 1 and minus. So now here possible number of nodes in a given network, 1 in a graph 1, 2, 3, 4 and 5. So now here number of rows are here 1, 2, 3, 4 and 5. Next number of branches 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Number of nodes cross number of branches. So the matrix size is 5 by 7. So now here fill this elements in the matrix here in the instead of 5 by 7. So now here one node from the one node. So one branch is living away from the node. So one branch from the one node. So one branch is living away from the one node. One branch is living and 4 branch is living and 6th branch is living. So all 1, 4, 6 elements are living away from the node 1. So all elements. So this one 1, 1, 4, 6 are elements are living, and remaining elements, remaining branches are not associated to this one. So 3, 5, 2, 7 are not associated with 1. So this value is 0. So now here remaining elements are 0. So now next case here. Now next, this first row is okay from the second row. So second row associated branches here 1, 3 and 2. So here 2 and 1 and 2 are entering, means that is minus. So 1 and 2 are entering direction, means minus, and 3 is leaving, that is plus. And remaining elements 5, 4, 6, 7 are not associated. So now here these elements are 0. Now second row is over. This row is over. Next case. Third elements, third row is this one. Third node. So this one, third row. So now here what are the associated branches here? 5, 2, 7. So now here 2 is leaving, 7 is leaving and 5 is leaving. So 2 is leaving plus and 5 is leaving plus and 7 is leaving plus. So this is plus, and remaining elements are not associated, and that elements are 0. So now 1, 2, 3 over, and next fourth node. So next fourth node, from the fourth node. So this 4, 3, 5 are entering to this fourth node. So that 4, 3 and 5 are entering to the node, means that is minus. And next case, fifth node. So these 6 and 7 elements are entering. So now that direction is entering, means that value is minus 1. So now this is 1, 2, 3, 4, 5. So now here in this case, so now here this is the incident matrix. So now here this is minus, this is minus. This okay. So now here next tie-set matrix, number of loops cross number of branches. So now here, so here in the this is tie-set. So in this is reduced incident matrix by using matrix manipulations, by eliminating the last row from the matrix A. So if you eliminate it, so this is the reduced incident matrix A. Next, tie-set matrix. So tie-set matrix, number of loops cross number of branches. It is represented with capital B. So here possible number of loops 1, 2 and 3. So now here select one tree. So here if there is no tree is not given, so select for that particular case assume the directions in clockwise direction. But here I am taking one tree here. This is the tree. This is the tree. So now remaining elements are links here. 4 is the link and 2 is the link and 7 is the link. This is the tree. Tree means it consists of all nodes. It consists of all nodes and without any closed path. So if you connect the links, there is a closed path. 7, 2, 4 are links. So these are the links. So now here I am taking link direction is the, in the previous problems I solved without tree. So just I taken. So now here that directions in clockwise direction. Here link direction you consider here. So now here this link direction is like this. So this direction should be like this, and this direction should be like this, and this direction should be What is the link here? 2 direction. So here fourth link direction is in anti-clockwise direction, and this seventh link direction is in anti-clockwise direction, and fifth 2 direction is in anti-clockwise direction. Now here this B matrix, number of branches. Here how many number of branches? Here 7, and number of loops are 3. So 3 by 7 is a matrix size here. So here tie set 2 link I am considering this one. So here tie set 2 means here this 2 tie set 2, here this is 2. Here for this case the associated elements are 2, 3 and 5. 2, 3 and 5. So 2 is same direction and 3 is same direction. So 3 is also same direction, and 5 is minus direction, opposite direction. In this also same 0, +1 and -1. If it is not associated, branch orientation is not associated with that loop matrix, loop direction. Next, that value is 0 if it is same direction, loop orientation, and the branch orientation is same direction, that is plus, and if it is opposite direction, that is minus. So now here tie set 2, here tie set 2, here this is 2, here tie set 2. For this case, so here 2 and 3 are same direction, and so this 5th direction is minus opposite direction. Next case, in the fourth link, so here fourth link, fourth one is plus as it is, and next here 3 is opposite direction and 1 is opposite direction, minus and minus. And next the seventh link, not associated elements are 4 is not associated element, and 2 is not associated element. So now here, so this direction, 6th is -1, opposite direction, this 6th is -1, and next 1 is same direction, this one, and third is same direction, this one, +1, and next here 5th is opposite direction, it is flowing in this direction. So now here it is flowing in this direction, means this is minus, and 7th is same direction, is +1. So now this is the loop matrix for this particular graph. So now here cut set matrix. So F cut set matrix, here first select one tree. So same tree I am selecting here. Here number of F cut sets. In the previous case we considered in the loop matrix only links, but here twigs we will consider. Twigs means tree branches are known as the twigs. So here this remaining elements, so here the previous case 2, 4 and 7 we considered, but here in the F cut set matrix 6th twigs we consider. So 6, 1, so 6, 1, 3, 5. So 1, 3, 5, 6 are the tree branches, so that are twigs. So these twigs, so F cut set 1, 3, 5, 6. So 1, 3, 5, 6. So one to form a F cut set 1, there must be one twig. So one twig, and remaining elements are links here. So now here in the same case, so now here, so first twig, here associated elements are here. Let me change the color over here, first one. So one element associated 1, 4 and 7. This is the twig. So this direction should be like this. So now here 1, 4, 7 directions you consider. So 1 is same direction, 1, same next, and next fourth direction is same direction, downwards direction, so +1, and 7th direction is opposite direction, -1. If it is +1, -1 and 0, if it is not associated 0 and the F cut set direction and the branch direction is same direction, then that value is plus, and if that F cut set direction and branch direction is opposite direction, that is minus. Here number of F cut sets are here 4 and number of branches are 7. So number of F cut sets here depending upon the number of twigs in a tree. So now here in this twig, here we have 4 number of twigs. So now here second case, so this is okay, this F cut set okay. Next second F cut set is for 3. So for this tree, number of links are here 3, 4, 7, 2. 3, 4, 7, 2. So now this direction is downwards. So the twig direction and this F cut set direction must be same, and this 3 is always same place 1. And next remaining links direction. So now remaining links direction means, so this 3 means here downwards means fourth direction, fourth one is also downwards, this one okay. Next this is downwards and this one is from this direction to this direction. Now this is minus, 2 is minus, and 7 is also like this. So this is minus opposite direction. 4 and 2 and 7 are opposite direction, and fourth and third our branch directions are same direction minus. And next case here, fifth one is here, fifth branch means here 3. So fifth direction is should be like this. So all are positive, same direction. So 2, 5, 7. So 2, 5, 7 are associated branches, so that are same direction in the direction of this F cut set 5, and that values are 1, that elements are 1, 1, 1. And next F cut set 6 direction, F cut set 6 direction means this one. So this direction means here, so this direction. So this direction should be like this. So 6th direction and 7th direction is same direction. So plus 1 and plus 1. So now here in this way, for the incident matrix, number of nodes cross number of branches, and this number of loops cross number of branches, and number of F cut sets cross number of branches. So now same way, second problem, for the circuit, draw the oriented graph and write the incident matrix, tie set matrix, and F cut set matrix. So first here, this is the graph. So now here the procedure I given here. So all resistors, inductors, and capacitors are replaced by line segments. And next, voltage source is replaced by short circuit, and current source is replaced by open circuit. So now here, this is the graph. Same thing. This one is 1 and this one is 1. This is 1 and this one is 1. So now this is the graph. Now assume the directions of the all branches. So now these are the directions, number of nodes 1, 2 and 3, number of branches 1, 2, 3 and 4. So this is the graph. So for this graph, determine the incident matrix, tie set matrix B, and cut set matrix C. So it is also represented with Q also. So now here incident matrix, number of nodes cross number of branches, here number of nodes 3 and number of branches 1, 2, 3, 4. Now here, so from this 1 is entering, that is minus, and 2 is leaving, that is plus, and 4th is entering, that is minus, and 3 is not associated. And next for the second node, and 4th is leaving and 3 is leaving, so plus, and remaining 1 and 2 are not associated. And next for the third node, 1 is leaving, that is plus, and 2 is entering, that is minus, and 3 is entering, that is minus, and remaining 4th branch is not associated. So now this is the incident matrix A. So it is represented in the matrix. So if you eliminate the third row by matrix methods, so now this is the reduced incident matrix. So now tie set matrix. So first select one tree. So here select one tree. Here I am selecting this 1 and 2. 2 and 4th. So 2 and 4th are twigs, and 1 and 3 are links. So 1 and 3 you consider here. So here possible number of loops. This link direction should be this loop direction, and this link direction should be this loop direction. So here tie set 1 and tie set 3, tie set 1 and tie set 3. So this one direction is same direction 1 and 2 direction is same direction 1. Remaining 3 and 4 are not associated with this loop. And next, same way, this third tie set this one, third branch, third link tie set this one, and in this for 1 is not associated. So this direction should be here -1, and this is, so second is -1 and third is same direction and fourth is -1. So observe this. So this is the cut set tie set matrix for this particular graph. So now here F cut set matrix. F cut set matrix is represented with CRQ. So now here, so for this part, in this case we consider only links. Here in this case we are considering the twigs. Twigs means 3 branches are known as the twigs. So here twigs means 2 and 4. So here what are the twigs here? So for this cut set 2, and this one is the link. So this twig direction is downwards direction. And next case, for this one, for this case, and 4 and 3, this direction should be like this. Twig direction is always F cut set direction. So now here 4 and 3 are associated. So and this one. So now here I am considering this one. Fourth element is not associated here. That value is 0. And 2 is same direction. And 3 is same direction. And 1 is opposite direction. That is minus. So is this okay? First row. And that is 2 F cut set 2 and F cut set 4. Here same. So 2 and 1 are not associated. Only this fourth and third and fourth are the same direction. So that value is 1 and 1. Next, for the circuit, draw the oriented graph and write the incident matrix, tie set matrix and cut set matrix. So first here, this is the circuit. So for this case, all elements are replaced by short circuited and current source is replaced by open circuit. This should be open circuited and this one is replaced by short circuited. Now, that means line segment. So if you draw the graph here, this is the graph. So now here this is open circuit. So now the graph should be like this. So the graph should be like this. This is open circuit. It is redundant. So now here, so this is the graph. So now here incident matrix can be, so number of nodes 1, 2 and 3, branches 1, 2, 2, 3 and 4. And next here in this case, so now here number of nodes 1, 2 and 3, branches 1, 2, 3, 4. So from the first node, 1 branch is entering means that is minus, and 3 branches entering means that minus, and 4th branch is leaving means that is plus. So -1 plus 1, and second node, second branch is not associated with node 1. Next second node and 2, 3 and 4 are associated, and next here in this case 2 and 3 are leaving, 2 and 3 are leaving, and 4th is entering, so that is minus, and 1 is not associated, that is 0. And next here for this third node, and 1 and 2 are associated, 1 is leaving, that is minus, 1 is leaving, that is plus, and 2 is leaving, entering, that is minus. So this is the tie set incident matrix. That matrix size is 3 cross 4. And next, if you eliminate this third row, so it is a reduced incident matrix. And next, here possible number of select one tree. Here I am selecting this tree only, this tree. For this case 3 and 4 are links. So now here for this tree, 3 is this direction. What is a clockwise direction or anti-clockwise direction? It is in anti-clockwise direction in the direction of 3, and it is in clockwise direction in the direction of 4th branch direction. So that loop matrix tie set direction is always in the direction of link direction. Now here this third one, so 1 and 2, 3 direction, 1 direction is opposite direction minus, and 2 direction is opposite direction minus, and 3 direction is same direction plus 1, and third one, fourth one is 0. And next here 3 and 4. So 3 and 4. So this one. So fourth one is same. Here 2, 1, 4. 2, 1, 4. So this direction is clockwise. So fourth 1 and 4. All are 1. So same direction in the direction of 2, 1, 2, 4 are associated and 3 is not associated with this one. In the tie set A, there only one link only. There must be one link, any number of ticks. So next, this is the this matrix size is here 2 cross 4, and next F cut set here, this is we considered here 1 and 2 are twigs and 3 and 4 are links. So this for this F in the F cut set we consider only twigs. Number of twigs equals to number of F cut set. In case of this tie set matrix, number of links equals to number of tie sets. Now here F cut set 1, here this is F cut set 1, so this direction should be like this. And next here this is 1 is same direction and 3 is this direction, and so this is same direction, and fourth is this direction, that is opposite direction, that is -1. And next this for this 2 here two branch direction here. For this 2, this is enter living, this is living, and this is living, and this one is living. So now here this direction, this F cut set 2 direction, this direction, this is same direction, 3 is same direction, and this 2 is same direction, and fourth is opposite direction, minus. For the circuit, draw the graph and draw its tree and write the fundamental cut set matrix. So this is the all elements are replaced by short circuit line segments, and voltage source is replaced by short circuit, and current source is replaced by open circuit. So this is the graph. So see the graph first. This graph should be like this. So now here possible number of nodes 1, 2, 3, 4 and branches 1, 2, 3, 4, 5 and 6. So these are the branches and nodes. Total number of branches are 6 and total number of nodes are 4. So now here cut sets. So first select one tree here. The selected tree is here 2, 4 and 5. So this is tree branches are twigs, and here for this one, this branch. So let me change the color over here. So this direction should be twig direction. So this is okay. And next this direction should be this one, this direction in the direction of twig direction, fifth branch direction. This is in the fourth branch direction. So now, so what about the matrix? Same thing here. So in this direction, same if it is this one in this direction. So 2 is same plus 1 and 1 is same plus 1 or minus 1. So this 1 is entering and it is this one. I think this is minus. And next here third is leaving. Third is leaving means this is minus. And next fourth branch here. Fourth branch here, fourth one this direction. So this is 1 and sixth is 1 and 3 is entering. This is minus 1. And next in this case fifth one. So associated elements 1. This is downwards. 5 and 6 are downwards. So 5 and 6 and 1, and this one is minus. I think this should it should be in minus downwards direction. For the graph of network, so write the incident matrix, tie set matrix and cut set matrix. So first here, this is the graph. For this graph, find out the cut set matrix, tie set matrix and incident number of nodes here 1, 2, 3, 4 and branches 1, 2, 3, 4, 5, 6. So now here these are the branches and nodes. First incident matrix. So now 1, 2, 3, 4 and 1, 2, 3, 4, 5, 6. So now here, so first node associated elements are 1, 4, 6. So 1, 1, 4, 2, 1, 4, 2 and 1 is entering, that is minus, and 2 is leaving, that is plus, and 4th is leaving, that is plus. And next for the second node, 4, 5, 6 are leaving. For second node, 4, 5, 6, 4th is entering, that is minus, and 5, 6 are leaving. And next third node, 2 is entering minus and 5 is entering minus and 3 is leaving plus. And next here next for this, and 1 is leaving, so plus 1, and 6 is entering minus and 3 is entering minus. So now here this is the reduced incident matrix if you neglect the last row. Loop. So I considered here this is the tree. So these are the links here. Links I am representing with this color. So here links are 1, 2, 3. 1, 2, 3 are links. So link direction should be loop, tie-set direction. So let me change the color here. So this direction is in this direction, this direction is in this direction, and this direction should be, it is in the direction. So now here in this, so 2 is plus 1. Sorry, first loop 1. So 1 is 1 same direction, and 4th is same direction, and 6th is same direction. So this is okay. And next second one, this direction 2, 5. 5 is minus, 2 is plus, and 5 is minus, and 4th is minus. This direction. And next here this direction, so not this direction. So this direction 3 is plus and 6 is minus and 5 is same direction, plus 1. So now this is the incident tie-set matrix. So here 3 cross 6, this matrix size. So next F-cut set. Here we will consider here 4, 5, 6 are twigs. So in the previous case links we consider. So now here F-cut set 4 here, F-cut set 5, 6, fourth one, this one, and this one. So now the directions here. So this direction, twig direction, and next this direction is twig direction, and this direction is downwards direction, 6th twig direction, 6th branch direction. So for this 4 associated branches are 4, 1, 2, 4, 1, 2. For this 3, the associated branches are 2, 5, 3, 5, 2, 3, and this 6th branch elements are branches are 3, 6, 1. This one. So now here see the orientation and fill the elements first here. So first one, fourth one. So 1 is opposite direction minus 1, and 2 is same direction, and next 2 is same direction, and fourth one is same direction. This row is okay. Next second case here, this one, fifth one, this fifth one. So fifth one is always this one. Sorry, fifth one is always plus 1, and this 3 is opposite direction minus, and this 2 is same direction plus 1. And next in this case here, this one here 6th is plus 1, and 3 is up same direction plus 1, and 1 is opposite direction minus 1. So now this F cut sets, number of F cut sets means number of twigs here 3 and cross 6. So now here for the graph network, write the incident matrix, tie set matrix, and F cut set matrix. This is the graph. So here incident matrix, number of nodes 1, 2, 3, 4, 5. So total number of nodes are 5, and number of branches here 1, 2, 3, 4, 5, 6 and 7. So these are the 7 branches. So if it is same direction, that is okay. plus 1. If it is opposite direction, if it is entering to the node, that is minus, and if it is leaving away from the node, that is plus, and if it is not associated, that value is 0. According to that, you fill the values. So here from the 1 is leaving away from the 1 and 2, so these two are plus and remaining all elements are minus, and 2 is entering, and 2 is entering means plus, and remaining elements here 2 is entering means that is minus, and remaining 3 and 5 are leaving. Here 2 is entering, so these two are 5, and for this 3 is entering, that is minus, and 4th is leaving, that is plus. And next case, 4th one, and here entering elements, what are the entering elements? 7, 4, 3 and 5 are entering. 7, 3 and 5, 7, 4 and 5 are entering, that is minus, and 6 is leaving, correct, that is minus, plus. And next, for this case, 1 is entering, so minus, and for the 5th node, 1 branch is entering, and next 6 is leaving, so next 6 is entering, that is minus, and 7 is leaving, that is plus. So this is the incident matrix 5 cross 7, number of nodes cross number of branches. If you eliminate any one of the row, so this is the reduced incident matrix. Next, tie-set matrix. So here for this tie-set matrix, this is the graph. So for this graph, here possible number of links. This is the tree. So links are here for this one and this one, and here 5, 6, 7. 5, 6, 7 are links, and for the 5 associated branches are 5, 3, 5, 3 and 4. So here, so 5 is same, and remaining 2 are, these two are opposite direction. Opposite direction, minus, minus. And for the 6th one, so for the 6th one, so 1, 2, 3, 4 and 6. 1, 2, 3, 4 and 6. So this direction should be here same direction. So same direction, 2, 3, 4 and 6 is same direction, and 1 is minus, and remaining elements are 0. This 5 and 7 are not associated. Next here, so here in this case, this direction, but here this direction should be like this. So minus, 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 and this is minus, and this is the plus. Next, F-cut set. Here for this tree, how many branches? Here tree twigs are 1, 2, 3, 4. So here first tree F-cut set 1, 1, 6, 7. So this one. So this direction should be like this. So this is 1, 6 are same direction, and 7 is opposite direction. So this is minus. So is it okay? Second one. And next case here, this one, second one, this one, 2, 6, 7. So 2, 6, 7. So this direction. So 6 is opposite direction, and 7 is same direction. So 6 is opposite direction, 7 is same direction. Next here, third one. So here, the third one, 3, 5, 6, 7. 3, 5, 6, 7. So now here, 3 branch direction is in this direction, 5 is same direction, 3, and 6 is opposite direction, and 7th is same direction. This is minus. And next for this fourth one, so fourth one is direction should be 5 direction is same, and 4th direction is same, and 6th direction is here minus opposite direction, and 7th is same direction 1. This is F cut set 1. So now here for the graph network, here write down the incident matrix, tie set matrix, and cut set matrix. So this is the number of nodes 1, 2, 3 and 4. Number of branches 1, 2, 3, 4, 5, 6, 7, 8. So total number of nodes are 5 nodes here and 8 branches. Here this is the incident matrix. So now here in this, so for the first node associated elements are here for 1, 4, 7. So 1 is leaving, 5 is leaving. So 1 is leaving, 5 is leaving, that is plus, and 4th is entering, that is minus. And next case here for the second node, 2 is entering, 1 is entering, that is minus, and 6 and 2 are leaving, that is plus. And next here third node, so here 2 is entering, so 2 is entering means that is minus, and 3 and 7 are 3 and 7 are leaving away from the node. And next for the fourth node, and fourth 4 and 8 are 4 and 8 are leaving currents, and third branch is entering current, that is minus. And next for this fifth node, so all are entering currents 5, 6, 7, 8. So these are minus, and remaining elements are not associated. If you eliminate one row from this matrix, so this is the reduced incident matrix. Next, what about the tie set matrix? Tie set matrix, number of loops here. So here I am considering this Z type tree. Here what are the links? 4, 8, 6 and 2. 4, 8, 6 and 2. So here for the 2, 4, 6 and 8 associated branches here, 2 for these 2 associated elements, 2, 7, 5, 1. So 2, 7, 5, 1. So now this direction should be this link direction. So 2 is plus 1, 7 is plus 1 and 5 is minus 1. And 2 is same direction, 1 is same direction. So this row is okay. And next tie set 4 is here, this direction should be in the clockwise direction, the direction of fourth direction. Fourth is plus 1 and fifth is plus 1, and next sixth is minus 1, opposite direction, and eighth is opposite direction. So here this is seventh is opposite direction, and not at a time 2 links should not be here. So now 7th is opposite direction and 3 is same direction. And next sixth one, for this sixth loop here only 2 here, this one. So 1, 5, 6. So 1, 5, 6 means, so here this direction should be like this, 5, 5th to minus and 1 is plus. Opposite direction, this is 2 or plus. And for the 8th one, these 2 only. So now this direction 8 is plus and 7th is minus and 3 is same direction. Next, cut set matrix. Here we are considering this one only. So now let me change the color. So now here this is the F cut set one. So twigs are 1, 5, 7, 3. So this one. So for the F cut set 1, so 1, 6, 2. 1, 6, 2. Here 1, 6, 2. Here this direction should be like this. So 6 is opposite and 2 is also opposite and 1 is same direction. And next F cut set 3 here. So this one, this twig direction is like this, and 3 is same direction, and 8th direction here associated elements, 8th direction is opposite minus, and 4th is also opposite minus. So 3, 4, 8. And next case here, so now here next fifth one associated are 5, 4, 6, 2. Fifth one 5, 4, 6, 2. Here this direction should be the fifth one direction, downwards direction. So see the directions here. So fourth one is opposite direction minus, and fifth one is always plus in the direction of fifth one. And next sixth one is same direction in this direction, plus direction, and 2 is same direction, plus 1. And next case, seventh one, this one, seventh one, at a time 2 should not be here. So this one. So this direction should be like this. So 7, 2 and 8 and 4. So fourth one is plus 1, and next here 7th one is also plus, and 8 should be plus, and next here 2 should be minus. 2 should be minus. So this is the F cut set 2. So now here, how many number of trees for the possible graph here? So for this graph here, so all elements are replaced by line segments, and voltage source is replaced by short circuit, and current source is replaced by open circuit. For this is the graph. So this is the graph. So now here, first, to determine the possible number of trees here, so how many trees here, possible number of trees. So there is a formula. First determine the complete incident matrix. So here 2, 3 and 1, 3 nodes, 1, 2, 3 and 1, 2, 3, 4 are branches, 3 cross 4. And next in this, so now here 1, so one branch is entering, that is minus, one branch is entering, sorry, so one branch is leaving from the node plus 1 and 3 branch is entering and 4th branch is leaving and entering. And next here 2 is 1 is entering minus and 2 is leaving and remaining elements are 0. And next for this 3, 2 is entering minus and 4, this is leaving and this one is entering. And the reduced incident matrix A is, if you eliminate one row, here this is the reduced incident matrix, and A, this is the A matrix and A and AT. So this is A and this is AT. Now multiply it. So this is, and find out the magnitude, means this magnitude. So that magnitude is 5. So now here possible number of trees are 5. So now here, if you draw the possible number of trees first here, so this is 1 tree, so 2, 3, 1. So next another tree is here 2, 1 and 3. And next another tree I am drawing here 2, 1 and 3. And another tree I am drawing here 2, 1, 3. So next one here, so what is the graph here? 1, 2 is okay. Next, so now here this is 1, 2, 1, 3. So this one, not this one. So total number of trees are 5. If you still have any doubts in this lecture, you can, I hope this lecture is clear to you. If still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.